Alright, today we're going to finish talk some more about trigonometric functions of any angle. Alright, so what they're going to talk about first is your quadrants and what their signs are. If they tell you, okay, they're going to give you one trig function value and the sign of another, and you have to find another trig function value. Well, you've got to decide what quadrant you're in before you can do anything. So if they tell you you're between 0 and 90 degrees, you're in quadrant 1. Or if they tell you you're between 0 and pi over 2 radians, you're in quadrant 1. If they tell you you're between 90 and 180, or pi over 2 and pi, you're in quadrant 2. If they tell you you're between 180 and 270, or pi and 3 pi over 2, you're in quadrant 3. And if they tell you you're between 270 and 360, or 3 pi over 2 and 2 pi, you're in quadrant 4. Yeah, that made kind of a cute little diamond. Alright, so what you have to remember, okay, is that your sine is y over r, your cosine is x over r, your tangent is y over x, and then your cousins are the opposites. Well, in this quadrant, and remember r is your radius or your hypotenuse, and it doesn't have a sign. It's not technically positive or negative. It's your hypotenuse, and we don't measure direction. So, but what I'm saying is we don't have to worry about the signs coming from the radius. We just have to worry about the sign of the coordinate. So if you're in quadrant 1, sine is basically y over r. Since y is positive in quadrant 1, then sine is going to be positive. Since x in quadrant 1 is positive, cosine is going to be positive. And since tangent in quadrant 1 is y over x, you have a positive divided by a positive, which makes tangent positive. Okay? And let's do this for all the other quadrants. In this quadrant, x is negative and y is positive. So since sine is y over r and y is positive, sine is positive. Cosine is x over r, but since x is negative, cosine is going to be negative. And tangent is y over x, which means you have a positive divided by a negative, which gives me a negative. And the cousins always match their partners. Alright, in quadrant 3, sine is y. Y is negative in quadrant 3, so sine is negative. Cosine is x, x over r, but remember r doesn't have a sign. So whatever x is what cosine is. Since x is negative, cosine is negative. How did tangent turn positive? Well, tangent is y divided by x. You have a negative divided by a negative, which is going to make a positive. And in quadrant 4, x is positive, y is negative. So since sine is y over r, sine is negative. Cosine is x over r. Since x is positive, that's positive. And tangent is y over x, which is a negative divided by a positive, which makes it negative. So you can figure out what quadrant you're in by those clues, and then we can go about our business. Alright, so it says, given that tangent theta is negative 2/3, so they're telling me that tangent is negative. And cosine is greater than 0, so they're telling me that cosine is positive. So I need a quadrant where tangent is negative and cosine is positive. Well, if I go looking, here, tangent is positive. No. Here, tangent is negative. Yes. Tangent is positive. No. Tangent is negative. Yes. So right now, this limits me to quadrants 2 and 4. So out of 2 and 4, I need the one that has a positive cosine. So in this quadrant, cosine is negative. No. This quadrant, cosine is positive. Yes. So that puts me in quadrant 4. So all you do is you draw any angle. It does not have to be drawn to scale. Just draw any angle in the right quadrant. I'm in quadrant 4, so I dropped an angle in quadrant 4. Okay, there's my angle. Now, drop an altitude, make a right triangle. Alright, and it says that tangent is negative 2/3. Well, when they say tangent is negative 2/3, I don't know which one is negative, the 2 or the 3. Well, figure it out. The direction will tell you. This is opposite. This is adjacent. So if this is my theta, my reference angle is what we're going to call that. Here's my reference angle. Opposite of that is 2. Adjacent to that is the 3. Now, which one is negative? Well, 3 is going to the right, so that has to be positive. But 2 is going down, which means that has to be my negative 1. So see how you figure that out? All right, so now that we've got my picture drawn, what the heck do they want? They want cosine and they want cosecant. Well, to get cosine, I need hypotenuse. I need the radius, so I'm going to have to find that. So I have leg squared plus leg squared equals hypotenuse squared, but in this case, that's going to be my radius, right? So I have 9 plus 4 equals radius squared. That's 13. So radius equals the square root of 13. Alright, so now that I know that that's the square root of 13 with no sign, hypotenuse doesn't have a sign, I can do what they want me to do. They want me to do cosine theta. Cosine theta is x over r. My x is 3. My r is the square root of 13. And I'll rationalize in a minute. Let's just find what they want. Then they want cosecant theta. Cosecant theta is r over y. So my r is the square root of 13. And my y coordinate was negative 2. So if we clean these up, rationalize this one, multiply top and the bottom by the square root of 3, I get cosine theta equals 3 square roots of 13 over 13. And I get cosecant theta equals negative square root of 13 over 2. I like these. These are like little puzzles. Okay. Let's try another one. We have sine theta equals negative 12/13. So they're telling me that sine is negative. But this is nice. They already told me that I'm in quadrant 3, and sine is negative in quadrant 3, so we're good. So draw a ray, drop an altitude back up to the x to make your right triangle. Here's your reference angle. So from there, they're telling me that opposite is 12 and hypotenuse is 13. So opposite of this angle would be 12. Hypotenuse would be 13. This is negative, so one of those things has to be negative. Well, 13 can't be the negative because it's the hypotenuse and we doesn't have a sign. So, and look, 12 is going, we're going down, so that makes it negative. All right, so they want all of the other values, which means I'm going to have to find the other leg. So I have leg squared plus leg squared equals hypotenuse squared. So I have 144 plus leg squared equals 169. So we're going to have leg squared equals 169 minus 144 is 25 square root, and the other leg is 5. Now, is that other leg positive or negative? Well, it's going left, which makes it a negative. Alright, so we already got sine. Sine theta is negative 12 over 13. Cosine theta is going to be, and if you want, if you like to use these instead of opposite and adjacent and all of that, your x coordinate would be negative 5, your y coordinate would be negative 12, so you would have x equals negative 5, y equals negative 12, and r equals 13. And then you can figure them out easier if you like. Cosine is x over r, so that's going to be negative 5 over 13. Tan theta is y over x, so that's going to be negative 12 divided by negative 5, which comes out positive. And then flip them over for the cousins. So cosecant theta is negative 13 over 12. Secant theta is negative 13 over 5. And cotangent theta would be 5 over 12. Okay? Alright, let's try another one. We've got cosine theta equals 8/17, and this says theta is between 270 and 360. Here's 270, here's 360, so I'm in quadrant 4. Okay, there's my reference angle and my right triangle, and it says that adjacent is 8 and hypotenuse is 17. So this is 17. Adjacent is 8, that's positive. Whatever the other leg comes out to be, it's got to be negative because it's going down. So to find the other leg, I'm going to have leg squared plus leg squared equals hypotenuse squared. and I get 64 plus leg squared equals 289. So leg squared, 289 minus 64 is 225. Square root of 225 is 15. So my other leg is negative 15. It's got to be negative because it's heading down. Alright, so now if you want to get this point, the x coordinate would be 8, the y coordinate would be negative 15. So you have x equals 8, y equals negative 15, and r equals 17. And now we can use this to find all of our functions. So I have sine theta equals y, which is negative 15, over r is 17. We got cosine, which they already gave us, was 8 over 17. That's x over r. Tan theta would be y, which is negative 15, over x, which would be 8. Flip them for the cousins. Cosecant theta would be negative 17/15. Secant theta would be 17/8. And cotangent theta would be negative 8/15. Okay? Alright, so another one. They're telling me that tangent is negative, so I need a negative tan. No, yes, no, yes. And sine has to be positive. So out of these two, I need a positive sign. Well, that's negative, so he's out. So I'm in quadrant 2. So draw an angle, drop an altitude. There's my right triangle in the right quadrant. Tan is opposite over adjacent. So opposite is 2, adjacent is 3. And it's negative, so one of those legs has to be negative. Well, 3 is going left, so that's negative. 2 is going up, so that's positive. So it's got to be the 3 that's negative. Alright, so I got to find the other leg. The hypotenuse. So leg squared plus leg squared equals hypotenuse squared, which in this case is our radius. So we have 4 plus 9 equals radius squared. 13 equals radius squared. So radius equals the square root of 13. So this point would be negative 3, 2, which means x is negative 3, y is 2, r is the square root of 13. So sine theta would be y over r. Cosine theta would be x over r. Tan theta would be y over x. Cosecant theta would be the square root of 13 over 2. Secant theta would be a negative square root of 13 over 3. And cotan theta would be negative 3 over 2. Now I've got to clean up these top two because they need to be rationalized. Notice I didn't rationalize until after I flipped because I don't want to rationalize 3 times. So sine theta would be 2 square roots of 13 over 13. Cosine theta would be negative 3 square roots of 13 over 13. And you have the other ones that don't need to be rationalized or simplified. So there's all 6 trig functions. Okay. Alright, so now we have a positive tangent, which would be here and here. So these guys are out. And they want a negative cosine. Well, that one's positive. This one's negative. So I'm in quadrant 3. Draw your triangle. And this says that opposite is 5 and adjacent is 12. So opposite is 5. Hold on a second here. Tangent is positive, cosine is negative. Oh, yeah. So opposite would be 5, adjacent would be 12, and they're both, you're going, how come it's positive if this is negative? Well, because this is left, it's negative, this is down, it's negative, and a negative divided by a negative is a positive. There we go. Alright, so now if I find the hypotenuse, I have leg squared plus leg squared equals hypotenuse squared. That's going to be 25 plus 144 equals r squared. 25 plus 144 is 169 equals r squared, square root, and r equals 13 with no sign. Alright, so that ordered pair there that it passes through would be negative 12, negative 5. So we have x equals negative 12, y equals negative 5, and r equals 13. So to find sine theta, it's y over r. Cosine theta is x over r. Tan theta is y over x. Cosecant theta is negative 13 over 5. Secant theta is negative 13 over 12. And cotangent theta is negative 12 over negative 5. These double negatives turn positive, and there you go. Alright, you try this one, hit pause, come back when you're ready. And hopefully you got negative square root of 33 over 7. Alright, they're telling me that cosine is positive and tangent is negative. So I need a positive cosine. And out of those two then, I need a negative tan, which would be here. So I'm in quadrant 4. Draw a triangle to the x-axis. This says that adjacent is 4 and hypotenuse is 7. So adjacent is 4, hypotenuse is 7. They want me to find sine. Sine is opposite over hypotenuse, so I'm going to have to get the other leg. So I have 4 squared plus the other leg squared equals 7 squared. So 16 plus leg squared equals 49. So leg squared equals 49 minus 16. And you get 33. So square root, and the other leg is a negative square root of 33. Why is it negative? Because we're going down. Alright? So if I sine from here, opposite is negative square root of 33, and hypotenuse is 7. Okay? Try this one, hit pause, come back when you're ready. And hopefully you got 4. Alright, they're telling me that tangent is negative and that we're in quadrant 2. So, quadrant 2, draw a triangle to the x-axis. This says that adjacent is 2, opposite is 2, and adjacent is 7, and one of them is negative. So opposite is 2, adjacent is 7. Well, 7 is going left, so it's negative. 2 is going up, so it's positive. And they want me to find cosine, which means I need the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. That's 4 plus 49 equals r squared. That's 53 equals r squared. So r equals the square root of 53. And they want me to do cosine, which is adjacent over hypotenuse. But I have to rationalize that. So multiply the top and the bottom by the square root of 53. And I get negative 7 square roots of 53 all over 53. Alright, try this one, hit pause, come back when you're ready. Hopefully you got 1. So they're telling me that tan is positive and that my theta is between 180 and 270. Here's 180, here's 270, so I'm in quadrant 3. Now this says that opposite is 8 and adjacent is 15. So opposite is 8, adjacent is 15. 15 is going left is negative, 8 is going down is negative, but a negative divided by a negative is a positive. They want cosine, so I need the hypotenuse, so I have leg squared plus leg squared equals hypotenuse squared. 225 plus 64 is 289. Equals r squared, square root, r equals 17. So the cosine from there would be adjacent, which is negative 15, over hypotenuse, which is 17. Alright, definitions of the trigonometric functions in terms of a unit circle. I'm starting this a little early. We're going to do this more tomorrow, but we saw that we can draw a point and find the radius. Well, if you're in the unit circle, this is the key. You have to be in the unit circle for your signs and all that to change. Remember how sine was y over r and cosine was x over r? Well, in this case, if you're in the unit circle, the radius is 1. So all of these are over 1. Over 1, which is why they just call them y and x. So if you're in the unit circle, meaning you have a circle where the radius is 1 unit, all right, whatever point you're passing through, this will always be 1 if you're in the unit circle. Your hypotenuse will always be 1 because from the center to any point on the edge is going to have a radius of 1 if it's in the unit circle. Okay, so that therefore sine becomes just y over 1, which is just y. Cosine would be x over 1, which is just x. And then tangent would be y over x still. Okay? Alright. And you are going to have to start memorizing your unit circle. If you'll watch this several times, the pattern is very simple. The first thing we do is we're going to label the axes. Alright, so you have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Because if you're in the unit circle, the radius is 1, which means those coordinates will be 1 unit right, 0 to the edge of the circle, because the radius is 1 unit long. The next thing we're going to do is start with all these fractions, okay? And all your denominators are 2's. Every single solitary one. So you just put a 2 on the bottom of every single fraction. Alright, the top numbers, the numerators. Well, there's a pattern. The outside pattern, which means I'm talking about here, 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 here. These numbers on the outside, the numerators on the outside, okay, they follow a pattern, which goes 1, 2, 3 counterclockwise. So watch it fill in. 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, on the bottom, sorry. On the bottom, you're just going to go reverse. Okay, instead of 1, 2, 3, 1, 2, 3, you're going to go 3, 2, 1, 3, 2, 1. Pretty simple. Okay, your inside numbers, you're just going to reverse the outside numbers. On top, you're going to go backwards. 3, 2, 1. 3, 2, 1, counterclockwise, and on bottom you're going to go 1, 2, 3, and 1, 2, 3. So now you have your numbers for all your fractions. Radical dude, if you're a 2 or a 3, on top, just on top, if you're a 2 or a 3, you get a radical. Okay? Next we've got to do signs. In quadrant 1, everything's positive. In quadrant 2, the x's are negative. In quadrant 3, the x's and the y's are negative. And in quadrant 4, just the y's are negative. Okay, so we put our signs in. Then we're going to get our degrees. Starting from 0, the pattern is add 30, add 15, add 15, add 30. So we would start at 0. Plus 30 is 30, plus 15 is 45, plus 15 is 60, plus 30 is 90. To get the next one, add 30, add 15, add 15, add 30. To get quadrant 3, add 30, add 15, add 15, add 30. To get quadrant 4, add 15, add 30, add 30, add 30, add 15, add 15, add 30. And you get all the way back to 360. Okay? There's your degrees. All we have left are the radians. The radians, it's very simple. In quadrant, the denominators in quadrant 1 go 3, 4, 6 from the top. Okay, so we have 3, see up here? Then we're going to have 4's here and 6's here. So 3, 4, 6. On bottom, we're going to go, guess what? 6, 4, 3. See how you have your 6's, then your 4's, then your 3's? Okay, so there is your denominators for your radians. Your numerators for your radians, they follow a pattern also. In quadrant 1, they're all pi's. No question, just 1 pi on top. In quadrant 2, what you're going to do is you're going to take your denominator, you're going to subtract 1 from it, and then stick a pi on it. So 3 take away 1 is 2 with a pi. 4 take away 1 is 3 with a pi. 6 take away 1 is 5 with a pi. Okay, in quadrant 3, you do the opposite. You're going to add 1 to the denominator and stick a pi with it. So 6 plus 1 is 7 with a pi. 4 plus 1 is 5, add a pi. 3 plus 1 is 4, add a pi. Okay, and in quadrant 4, there really isn't a pattern, so I just remember a silly saying that says, 5 days a week I go to 7-Eleven. 5 days a week I go to 7-Eleven. So there's your radians. We've got just our axes in radians that I have to do. It follows a pattern, and it goes from 0 to pi over 2 to 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2, which is 2 pi. So if you watch, I have 0 here. Up top, I'm going to have 1 pi over 2. Over here, I'm going to have 2 pi over 2, but that reduces to pi. On the bottom, I'm going to have 3 pi over 2. And on the edge, I'm going to have 4 pi over 2, which reduces down to 2 pi. And that, my friends, is how you memorize your unit circle. You will be having a test on this. You'll have to fill one out on your own. So start studying these patterns until you can fill it out without looking. Alright, so now that we know that, okay, we can actually find the exact value of the expression without using a calculator. This says, if you're in the unit circle, go to 5 pi over 3 and take the y coordinate, because sine of any angle, we're taking sine of 5 pi over 3, is y over r, but in the unit circle, r is 1. So you just go to that angle and take the y. So here's 5 pi over 3. If I take the y coordinate, I get negative square root of 3 over 2. So sine of 5 pi over 3 equals a negative square root of 3 over 2. Done. Because if you draw the triangle like we've done all along, this hypotenuse is 1. It has to be because it's in the unit circle. Alright, so tan of 7 pi over 6. Well, go to 7 pi over 6, which is right here. And tan says take the y and divide it by the x. So the y is negative 1/2 divided by the x is negative square root of 3 over 2. Simplify that. Keep, change, flip. The 2's can't, the 2's cancel. A negative times a negative is a positive, and you have 1 over the square root of 3, which I have to rationalize. So multiply by the square root of 3, square root of 3, and I get tan of 7 pi over 6 equals the square root of 3 over 3. Okay? Alright, cosecant of negative 2 pi over 3. Alright, to do this, guys, here's what I do. I don't count backwards very well. So, to get to negative 2 pi over 3, I'm going to go to positive 2 pi over 3, which is right here, and then I'm going to reflect down, which puts me right here. This will be a negative 2 pi over 3. So that coordinate's right there. So here's where I'm at, and to do cosecant, it's r over y. But in the unit circle, your radius is 1. So cosecant of negative 2 pi over 3 is 1 over the y coordinate, which is a negative square root of 3 over 2. To simplify that, I'm going to keep the top, change the times, flip the bottom, and I get a negative 2 over the square root of 3. But I have to rationalize, so square root of 3, square root of 3, and I get cosecant of negative 2 pi over 3 equals negative 2 square roots of 3 over 3. Okay? You do this one, hit pause, come back when you're ready. Just do this one. Oops. Sorry. I didn't put the unit circle on here. Hold on, here we go. Alright, so if you go to the unit circle and you go to 7 pi over 6, which, sorry I didn't put it on here, is right here. And it has the coordinates of negative square root of 3 over 2, negative 1/2. So to do my y divided by x, I'm going to have a negative 1/2 divided by a negative square root of 3 over 2. Keep, change, flip, cancels, and I get a positive 1 over the square root of 3, rationalize, and you get the square root of 3 over 3. Alright, do tan of negative pi over 2. Hit pause, come back when you're ready. And it should be undefined. If you look at your unit circle again, this would be positive pi over 2. So reflect down, this would be negative pi over 2. So I'm right here. That ordered pair is 0, negative 1. Tangent is y divided by x. The y is negative 1. The x is 0. And anything divided by 0 is undefined. Alright, so given the value of one trig function in the quadrant it is in, how do you solve for the remaining trig functions? Well, you draw your angle in the right quadrant. Find missing sides. Really, they gotta give you 2. And then solve. 5. How do you find the values of the sine, cosine, or tangent of a given angle on the unit circle in radians or degrees? Oh, on the unit circle, then sine is y, cosine is x, and tangent is y over x. And you can do the cousins, but those are the 3 they're mostly interested in, you know. Alright, so we're at homework, which means we're done. Happy homeworking, and I'll see you next time.